Hello, everyone. Um, my name is Jeffrey Brace. I'm hosting this month's TPUG meeting here, and today we have Jamie Idlepix. How do you say it? Pronounce their name?
That's Idlepix. My last name is Johnston. Idlepix is a handle, but
Oh, I said it right. Idlepix.
you
Very
did
good.
say it
Jamie
right.
Idlepix. Jamie is a self-taught in electronics and software development. He was introduced to the idea he could build electronic gadgets when he was 11 by a book he checked out from the school library. After that, no electronic device in the house was safe. Sounds like Jerry Ellsworth. On a weekly basis, his dad was not happy finding everything from toys, radios, TVs, and even his new camera in pieces. It took Jamie a while to develop the skills needed to put things back together without any leftover parts. I hate that when I do Legos. Writing code gave him the same sense of satisfaction he got from building electronic gadgets. The first computer he fell in love with was the Commodore 64, just like me. He acquired it by trading with another kid in the neighborhood when he was 12. What did you trade?
I can't actually I what I traded for the 64 was actually a Commodore 16 and a VIC 20. So he
Good
was like,
choice. Good
yeah,
choice.
like two computers for one. Okay. It's like,
He
okay.
learned everything he could about developing for the system. As an adult, he had done IT work for various companies, including Delta, Data General, EMC. Currently, he works as an independent contractor, solving his customers' business problems using the latest technologies. Jamie brings his knowledge of Commodore systems to FujiNet as well as code from Meatloaf project. So he will be talking about that today, his Meatloaf project. So I'm excited to hear about it. I've seen Jamie at various vintage computer festivals, VCF East, VCF Midwest, and just this past weekend, VCF Southwest. So I know Jamie, and he's always right next to Thomas Cherry Holmes working on FujiNet. So he's a great guy. So take it from here, Jamie. Welcome.
Thank you. Thanks, Jeff. Um, let's see. I guess I should start with explaining what Meatloaf is. And if you're familiar with what FujiNet is, it's kind of the same thing, but for Commodore computers. I was actually working on it before I even knew about FujiNet, and Tom had posted in one of the big Commodore Facebook groups on, um, he had posted on one, the big Commodore Facebook group about FujiNet and his interest in bringing it over to Commodore, and that's where I found out about their project and jumped in. I was like, hey, I'm already doing this on Commodore 64. So we kind of joined forces. We're sharing code between both projects. I'm still keeping Meatloaf as its own separate project just because there's some Commodore specific things that I want to do with it. And I can talk about some of those today. Um, I am actually recompiling the code right now so that I can demo it. I should have done this before we started, but it's compiling now and it's going to flash, and then I can demo the actual device. But let me switch over here. So Meatloaf it's a multi-device emulator. It doesn't just emulate a floppy drive, but it could emulate like a stack of 1541 drives or 1571, 81, whatever. It's not doing a cycle exact emulation. It's more, just a simulator, kind of like SD to IEC in that respect. But we can also emulate other devices, printers, modems, other things, anything that you would connect to an IEC port on Commodore computers. Let's see here. I talked about FujiNet. Um, Meatloaf is different than SD to IEC and Pi 1541 because it is not trying to be a cycle exact type device. And like I said, it can emulate multiple devices rather than just a single 1541. Um, I've gone through some of these slides and, well, all of these slides in other presentations, but I'll just go over them again real quick here. The basic, one of the basic functionalities of Meatloaf is just loading programs into the system, and you can do that using various methods, either flash or SD card loading, because the device, it does have some flash storage on it, but it also has an SD card slot, so you can pop an SD card slot, SD card in there with a bunch of files and load those individually. It can also load from a URL file, and it's just a simple text file with a URL in it with a .url extension. So if that is on the SD card or stored in flash and you try to load that, the device will read the file and then actually load the URL that's stored in the file. So that saves you from having to type a big long URL. I've also set up a shortcode system, and you access it using a scheme, URL scheme that it uses ML colon as the scheme rather than HTTP colon / or something like that. And I'll show that to you in a little bit. And also I wrote a browser add-on that's called Send the Meatloaf, and you load that in your browser, and then when you're browsing around the internet on your PC, if you find a D64 or PRG file on, say, CSDB or some other site, you right click on it and then just select Send the Meatloaf, and it queues that URL up in the Meatloaf.cc API and gives you a command, just a simple command that you can type in on your Commodore 64 to load that over the internet. So I'll show that as well. Let's see here. Next slide. Oh yeah, URL loading. So this is one of the great things about the device, and this was the main goal of it, was to be able to load programs over the internet, not just PRG files, but mount a D64 image sitting on a web server out on the internet, wherever it may be, and being able to access it just like it was like you just popped a disk into a drive. So you can enter a standard load command, but then give it a URL, and that URL can sorry, I'm getting a little tongue-tied here. One of the things that Meatloaf does is it abstracts a bunch of stuff. So that file can be out on a web server inside of a zip file, inside of a D64, and you just give it that long URL, http:// some domain, some file path, archive.zip / media file.d64, and then the file inside the D64 that you want to load, and it will load it. It will unravel all of that and return a stream that gets sent directly into memory on the 64, which is kind of cool. So my plan was to support just about every media file format that has ever been created for Commodore machines. Again, this works on any system with an IEC serial port on it. So that means VIC-20, the +4, Commodore 64, of course, 128. Also planning to build a little interface so we can do IEEE 488 for pets and other machines with that port on it as well. Another thing Meatloaf does on the fly is it translates PETSCII to UTF-8 and back. So if you try to read you can have it set up so that if you're loading a file, so you're reading a text file from the internet, it can translate that on the fly. So that's kind of a neat feature of the system as well. So this is what the original hardware looked like, and I originally built it on ESP8266. That's the WeMOS D1 Mini Pro. That little module has 16 megs of flash storage on it. And I started with a Wi-Fi modem. So I built that first, and this was just using the StrikeLink modem schematic. So this is wired up. This was wired up to the user port. And then the problem that I had is, I got the modem built, got it flashed, got it set up, but then I started thinking, I was like, well, if I don't have a floppy drive, then I can't, this modem is no use to me or anyone else if they don't have a way to load CCGMS or some other terminal program. And that's when I started thinking, it's like, well, got some extra IO pins. Let's build an IEC interface onto it so that we can at least load CCGMS. So that was kind of the start of this whole project. I just wanted to be able to load a PRG file, load CCGMS into the 64 and be able to get online and browse some BBSs. And that kind of kicked everything off. So this was, again, the original device that I built. I did use the level shifter there for the IEC lines, but the ESP8266 really doesn't need, you don't need those, you don't need the level shifter. I know there's a big controversy over whether the GPIOs are 5-volt tolerant on the ESP8266 and also the ESP32, but the CEO of Espressif flat out said that they are 5-volt tolerant and the level shifter is not needed. I have run into a few situations. It can't hurt to have the level shifter, but you don't necessarily need it. So I have run into one situation where I couldn't get it to connect to the Wi-Fi if the 64 was already on, and that adding the level shifter did resolve that issue. But I've also used it for a long time without the level shifter. So anyway, let's see. This is, okay, yeah, this is the hardware that I've been using for doing the latest development. This is a Lowland D32 Pro, and it specifically the Pro version. There's a Lowland D32, but that one uses a different module. So if you put one of these together, you want to get the Lowland D32 Pro. This one has the Rover module, which has 16 megs of flash. It also has 8 megs of PS RAM. We're not really using the PS RAM right now, but it's going to be useful in the future. Well, we're not using 4 megs of it. We're using 4 megs of it right now, but not the other 4 megs because you have to bank that other 4 megs in and out. It's a nice module. It's got this little SD card slot down on the side. Pop that in there, and it's a really easy way to build one of these and get up and going really fast. You flash it right over USB. All it takes is 6 wires and a DIN 6 plug, and you're good to go. So if you can solder 6 wires, you can build a Meatloaf device. And this is the bare minimal version of the device. The next version, the full blown version, is going to have a user port interface, and that is going to look like, I'll show you this one right here. This one that Moswald and I worked on. He did the PCB design and was able to get all of my ideas into it. This is all of the user port connection. All the lines on the user port are connected up. So we have full access to everything that you can do on the user port. And my plans for that include adding WIC64 support. If you've seen that device, it's pretty cool. So having all the lines hooked up will give us the ability to support all of the applications that run on WIC64. But we can also switch this between parallel and serial mode, so it will be able to act as a standard Commodore modem. So we'll have that. We'll be able to use all the old terminal programs that we used to be able to use back in the day, along with the device. But also the parallel mode will give us the ability not just for using all the WIC64 apps, but we'll also be able to use like Speed DOS and Dolphin DOS. kernels and really speed up the loading of stuff over the internet or from Flash or whatever. So this is, again, this is the full-blown version of the device. This is like everything in the kitchen sink that I could think of to put into it. There's also a strip of LEDs across the top to give some kind of indication as to what's going on during a load process. I figured I'd light up one for each 20% of a file load. So anyway, this device is experimental right now. We do have some modifications that we have to make to it before it will be ready to start producing. I was hoping to get all that done, last year, but had some life stuff happen that kept me from working on things as much as I'd like to. So I was able to get going again this year, and we've made some good progress on things. Let's see, next slide. Oh yeah, upcoming features. I've already started working on Jiffy DOS. I've got it reading bytes, but I don't have it sending bytes yet. So I have to figure out what's going on with that. So I'm not very far from getting Jiffy DOS working, and then once that's solid, we'll be able to knock out some of the other fast loaders pretty quickly. I was already talking about parallel loading with Speed DOS, Dolphin DOS, and WIC64 application support. And let's see, oh yeah, and opening, reading, writing, closing any supported file stream. That includes HTTP, TCP, UDP connections, zip files, 7-zip, D64, DD1, all the different protocols, all the different file formats. The goal of this is to be able to load anything from anywhere. And I believe it's doable. I mean, we're already doing a lot of it right now. There still needs to be some work on some of the other protocols and stuff, but everything's moving along. We're actually, over the weekend while we were at VCF Southwest, just before I left to drive to Dallas, me and Dan drove out to Dallas for the show. The night before, I was doing some testing, and I finally found what was causing my issues with the IEC serial protocol. The entire time I thought I was doing something wrong. I was doing a handshake wrong, something, because everything would work great for a good long while, and then it would just get out of sync and it would go off the rails. Well, I was doing some traces with a data analyzer, and I put some debug code in to figure out where each bit was being read off the bus, so I could see how long it was taking to read each bit of a single byte. And I realized that something was happening every once in a while that was causing the system to skip a bit, and that was that's what was causing the issue the entire time. I thought it was my code, which technically it is my code, but I was bit banging the protocol instead of using an IRQ instead of using an interrupt to read the bits. And once I switched my code around to read the bits using an IRQ, everything started working. So again, I couldn't work on it because I just packed everything up. I just discovered the issue and then started packing everything up to leave for VCF Southwest. So I wrote some code and then asked Mark in the FujiNet Discord to test it for me, and it needed some tweaking, but I'm pretty confident we solved the issue finally with the IEC serial protocol. Everything is working much better than it ever has, and I can show you what we can do with it now. So anyway, let's I'm gonna switch over here and let's zoom in. Come over here. I'm gonna reset the device. It's sitting here on my desk. I'm just gonna hit the little reset button on it, and there we go. So I'm gonna scroll back a little bit so you can see. Let's see. So it initializes. We get a message in this serial monitor, and it's just showing Meatloaf CBM. It's got a date on there. That's an old date, but These stats are kind of hard coded right now. These are some parameters that I want built into the device. So later, whenever when we have kind of a search engine, we can pass these parameters along with it. So it knows that we're doing a search for, say, Pac-Man. We want to return a version that will work on a Commodore 64 NTSC English, right? So these are some parameters that I was kind of adding to the system. They'll be configurable using either settings in like a web interface or maybe a program we just run on the 64 and it figures out what the system is and tells the Meatloaf device, and then it just stores it in a configuration on the system. So anyway, this is the serial console and some of the things that it does whenever it's booting up. So it's initialized the IEC bus, and this is where it starts creating the virtual devices. We've got a virtual printer on device 4, virtual disk drive on 8, we've got a virtual network device on device ID 16, and I'm actually using the FujiNet network device right there. Even though you can load things using the virtual disk device, this is using the Meatloaf networking there, but on network device number 16, that's actually using some FujiNet networking. And then we have a CPM device, and this was ported over from FujiNet, as well as this voice and clock virtual device. And then the main Meatloaf device itself is on device number 30, which is the maximum device ID that you can have on a IEC serial bus, of course. And then it just shows you right here, all these devices were initialized. Oops, scrolling to the side. Shows us some memory, the memory that's available. And it's connected to my network here and IP address. Okay. Boot it up, ready to go. Here's a web server. I did get web sockets going in the server as well as WebDAV. So all of those will be able to be used to access the Meatloaf device on your local network to do various things. Number one, web configuration. And I can show you a prototype of what I'm working on for that. It's not functional, but it's just trying to get all of my ideas into it, and I've got to build it all out and get it actually working, and it will be hosted on the device, so you can access it with a phone, tablet, PC, whatever. It's going to be responsive, so it'll work on each type of device and look nice. WebSockets, that's going to be a API interface so that we can do things with Meatloaf from other devices on the network. So you want, I don't know, see, you want to write a program that sends over configuration to the Meatloaf device. So you want to, I don't know, I'm still up in the air as to how I'm going to use that, but one of the wild ideas I had was tying it in with like Google Home or Alexa, and maybe use your voice to say, hey, load arcade.d64 on the Meatloaf device, something like that. I don't know. I was just brainstorming ideas, and I kind of want to work with some of that technology, and that will give me a reason to play with it. There's no telling what we'll come up with once we start playing with some of that stuff. But anyway, device is started up on the 64 over here. I'm going to do just a load a directory listing, and by default we start out from Flash, so we're just going to get a directory listing of the files that are in the flash storage of the device, and there we go. You notice up there at the top, let me switch over to HDMI only. We've got an SD folder, SD dir, and if we want to switch into that directory, if you have a wedge on your system, you can just use the standard SD to IEC commands and just do a CD right into that SD directory. But if you don't have a wedge loaded or a cartridge with a wedge, you can just load SD, and that will change directory into it and give you a directory listing. Loading, there we go. that is our directory listing. Let me show you one thing too that I modified with the listing, and I know some people may not like this because this is non-standard, is I added a few extra lines at the top of the directory listing to just show the path of where the Meatloaf device was. Right now we're in the SD folder, and if we change into one of these directories or load a PDF, not a PDF, if we load a D64, it'll show us that we've got that image mounted. Actually, let's do that real quick. Let's go into, let's see, let's want to test. Yes. CDN. We're just going to change them to that CDN directory. That's going to give us some other stuff in here. And say I want to load one of these D64 files. Say, let's load new. Load. Same thing with a D64, you just load it and it's going to detect that it's a disk image and mount it. So load comma 8. There we go. Come down here and list this. There we go. So now we're showing that our path is /sd/test/cbm/mule.d64. I know it's really long. Probably do something to shrink that down some, maybe some ellipsis or something. But it also shows us that we're inside of the mule.d64 image. And oh, another thing that I did with the listing too, since, we'll see, I've got to fix this because it should have shown blocks free, but it's actually showing us G bytes free from the SD card because we're inside the SD card. Since the D64 is mounted, it should be showing blocks for that D64 image. So anyway, I have to fix that so it shows the blocks correctly. But whenever you're in browse mode and you're browsing around the flash or the SD card, it's going to show you G bytes free or M bytes or K bytes, whatever. To change out of the D64, say we want to go back a directory, you can simply do a load CD back arrow 8, and that will send us back to the folder that we were in previously, right there. So makes it's just that those same CD commands that you would use with a wedge, you can use them with a load command here. I did include a like a special command. It's you do load CD up arrow, that will send you back to the root of the flash file system. Okay, so that's an easy, quick way to get right back to the root of the file system. Right here, if we load FB64, let me switch over to VS Code mode here and zoom in. I'm going to load FB64. And since I've got the data stream turned on, we can watch the file get loaded through the serial monitor. And it shows the address in memory where this file gets loaded. So I added that because when I was testing, I wanted to make sure that things were loading properly. So I can freeze the 64, go into memory using my action replay cartridge, and then check these memory locations to make sure this program loaded properly. It's kind of a, a neat way to, for testing and whatnot. So all right, let's run this. And file browser is up and going. So again, this is just browsing the flash file system and the SD card. But this also works over, works for browsing a web server. I've got a script, a PHP script that you can drop on a web server. Of course, it needs to support PHP, but it's just a simple PHP script that you drop on your own web server somewhere. And you can throw a bunch of files on the server, and then you can load that directly using Meatloaf on your 64. So if we wanted to load directly from my server, load to, I'm going to use the URL http c64.meatloaf.cc. Okay, 8. Yeah, I'm going to load that. There we go. Loaded that. What's this? Okay, this loaded directly from the server. And again, if you look at those lines at the top of the directory listing, we'll switch modes here so you can see a little bit better. It'll also show you the URL that you have mounted, so it gives you an idea of where you're at. Of course, I'm going to have an option in the configuration to turn off all of these funky special directory listing features so that you just get a standard Commodore 64 directory listing in case you're using some program that doesn't like, the stuff that I added. But I kind of like it. I think it's neat. So anyway, the script, the PHP script, I can. There's a link to it on the Discord so that you can download it, throw it on your server, modify it a little bit for your specific setup. You can change the the header of the directory listing to be, say, Jeff's archive, Jeff's Commodore stuff, if you want to do something like that. The great thing about this is, again, you can link from one server to the other. Like I've got a folder on my server. It's called URL right there. Let's load that URL. And that's got some URL files in there. So load URL listing. There we go. Okay, so there's a Citizen server with some stuff out there on the internet. So I can link from my server to another server using these URL files and this Gunstar 1. Let's see if that's up. Let's switch over here. Let's see, Gunstar 1. Actually, no. Let's load Citizen, because the Citizen server, because I was on that earlier, and I know that one's up and going. So load citizen.url, 8. And let me switch mode so you can see it loading. Right over here. Let's see. So there we go. It read the URL out of the URL file over HTTP. So that loaded from my server, read that URL, and now we linked over and we're listing files off of Citizen server. That's kind of cool, right? So that's how the URL files are used. I did mention that I have a short code system set up, and that is, you use that by just loading the short code. Say I've got ML colon let's see, ML colon game 8, and that is just going to directly load the listing from the oh shoot, it didn't like that file not found. Oh, maybe it's just game, the ML colon game. What that does is it hits the Meatloaf API and then looks up the short code and then returns a URL. Oh shoot, I'm getting it wrong. Let's do a load. I know one. ML. This was one of the very first short codes that I made because I love this little demo. It's IB. My mind is born. I'm sure you guys are familiar with this little 1-block demo. Really fast to load. So yeah, IB. There we go. We just loaded that one little demo one. There we go. Demo is running. Just loaded right over the internet. Let's see. Let me show you. I'll show you another short code too. That's kind of cool. This guy posted it on. He posted this program on Facebook Commodore group, the big Facebook Commodore group. Keith Amakis, I believe that's how you say his last name. And it's a nice little rock, paper, scissors game. So I just loaded this. I set up a short code to load this directly from his server. So anytime he updates it on his server, anyone can load ml:/rps and run it. And it's a little rock, paper, scissors demo. They just float around and, rock beats scissors, scissors beats paper, paper beats rock. And they just float around and attack each other until there's one winner. So kind of a neat little demo, but it's loaded directly over the internet like that using the shortcodes. Let me show you the send the meatloaf add-on. Let's switch over to the browser here. Oops, sorry. Browser. There we go. CSDB. So I'm gonna go. Let's see, top demos. I know there's one. There's one here called Love Cats. It's just a PRG file. Let's search for that. Love Cat. There we go. I know this is probably hard to see on. Oh, that wasn't it. Love Cats. Here it is. The release. Love Cats. I think that's the SID. So up here. And you just go down to the PRG file, and I'm going to right click on it and select send the meatloaf. And that queues the URL up to the meatloaf API, and then it gives you a command to load on the 64. It's just ml:/. Since both these computers are on the same Wi-Fi here, they both have the same external IP address, and that's what I'm using on the server to create a hash to store that URL on the server. So the next request that I get, it just creates the same hash, looks up that URL, and then sends it back to the device. So whenever you actually load that from Meatloaf, I'll show you. We're going to do load. Let me zoom back in. Load ml:/, 8, and didn't like that. Come on, try again. Erase that. ml:/, 8. There we go. Now hit the API. And it's loading directly from CSDB. We didn't have to download anything, copy it to an SD card, pop it into the system, and then restart the 64, and nothing like that. You just load ml:/* after you send the meatloaf. So that opens up the web to using that add-on, opens up the web to being able to load anything from just about anywhere. And you don't have to worry about typing a big long URL. You don't have to worry about typing characters that might not, show up on the Commodore 64 keyboard. You just right click on the link, send the meatloaf, and then enter the command and load it right up. So that loaded up. One. There we go. And it's loaded up and running. Kind of cool. So anyway, let's reset. All right, let's see. I'm gonna think what else I can show. Oh, let me show you this too. I mentioned that I have a WebDAV server set up on the Meatloaf device itself. So that makes loading things a little bit easier if you're doing some development and you want to copy things over to the SD card to load immediately. I use WebDAV for connecting to it. Or it's WebDAV, but I'm using CyberDuck. Let me move this over here so you can see better. Okay, so Meatloaf, the IP is 192.168.171. So there you go. I just connected to it, and I've got direct access to the SD card right here from my PC again, so I don't have to shuffle the SD card back and forth. And a lot of times you got to turn the 64 off or turn off like SD to IEC. Well, I don't know. Can you pop out SD card and then pop it back in on SD to IEC? Does it recognize that? I'm not sure. But anyway, you don't have to touch the SD card, move it back and forth, whatever. You can just connect to it over the network, drag and drop a file in here, and then it shows up on the Meatloaf device whenever you do a directory listing. Actually, let's see. Let's see. What do I have that we can over here? Let's see. 1943.t. Let's drop that in the root of the SD card. Like that. There we go. It's uploaded. And it's there. So now let's okay. It should show up in a directory listing. Let's change back to root. CD. Actually, we can do //sd, and that goes from root to the SD directory. So, there we go. And let's see where that is. There it is, 1943. See, that's the one that we just copied over the Wi-Fi using WebDAV and dropped it on the SD card. And now we're loading it in the memory. It's going to take a moment. Again, everything's running at standard IEC serial speed, so it's just as slow as a real 1541. Actually, it's slightly faster than a 1541 because we don't have the mechanical disk move, the heads moving around and blocking, but it takes more time to move around a real physical disk that's spinning than it does to jump around and load blocks from a file on an SD card. So it's actually slightly faster, and there's some things I can do to even make it even a little bit more faster. But really getting Jiffy DOS is what's going to be getting Jiffy DOS running, and the other fast loaders working with Meatloaf is going to be the big thing. So here we go. It's going to work. I haven't tried this PRG file, so it may, I don't know. It did load, but it's not like it for some reason. Okay. Sorry about that. So yeah, I think I've covered just about everything I wanted to talk about. Does anyone have any questions?
All right, so we're opening up to questions. If you want to ask a question, you can unmute yourself.
Please.
Well, while Alex, while people are thinking about a question to ask, so you said it loads at standard speed. Is there any future or possibility to have any fast loaders to load it at warp speed?
I'm working on that, and that will happen. I needed to get the standard IEC serial protocol solid first, and now I believe I've done that with the changes that I just recently made. Everything's looking way better, and I have got it to a point where it's reading bytes, Jiffy DOS bytes, but it's not sending Jiffy DOS bytes over the serial port. So I've made a little bit of progress in that area, and I hope to knock that out very soon. Actually, I'm still doing some testing on the standard serial protocol. But everything's looking good, and I'll be able to move on and really start hammering out the rest of the issues with getting Jiffy DOS working. So
It looks like you have action replay, so I guess using that as a sort of like a wedge in a way to make things easier.
um, mm, I've been using it mostly just to reset the system and clear the
Uh,
memory. I haven't been using any of the features of the action replay, except, well, I do use the machine language monitor. Like I said, whenever I load something into memory, I can see where it's supposed to load into memory in the serial monitor, and then freeze things, and then go examine it on the 64 side from the machine language monitor built into the action replay. So that's been really nice. Of course, Super Snapshot and some other cartridges have monitors in them as well.
so how long have you been working on this project? When did you start?
I built the Wi-Fi modem, the StrikeLink Wi-Fi modem, in probably 2018, 2019, somewhere around there. And then I start in 2019. It was definitely 2019 when I started adding the IEC interface to it. And um, I initially started, what did I do? Initially, I had started and I was using some kind of PC interface. It was the Uno to IEC code that I'd found on GitHub. And that was using an Arduino to load from a PC into memory on the 64. And I started with that, and I ported it over to work on ESP8266. And I used that as the base of the IEC driver for Meatloaf. And of course, I've built it out since then. There was a lot of issues with the code, the Uno to IEC code, but it was a good starting point for me and gave me an idea of what I needed to do to at least get something working. And I started as just a PRG loader, and then finally I got D64 file formats working, and from there I was able to really start hammering out the different file formats, because just about all of them are based on D64. So you can inherit from that and then change a few parameters, and then you've got D71, D81, D90 even, or DNP. So you got the ability to access all those different file formats with the Meatloaf device. In fact, I think it's probably going to be the device that you will be able to throw any file format at it, and it will be able to load it. That's the goal, at least. I know still have some work to do. Everything's read-only right now. We're not writing anything back to the file formats. So you can load, but you can't save at the moment. And that's another thing that's on the list that I need to work on.
Anybody have any questions now that you have a little time to think about it?
I'm going to load something up here too. This is something that loaded, or that I put together on the fly.
So this is still in beta. So right now, I guess you're still implementing it. It's not something that someone can buy or try out at the moment. Is that correct?
If they want to build the device, like I said, it's a Lowland D32 Pro, a DIN 6 plug, and a little bit of wire. If you can solder 6 wires, you can build one of these and load the firmware and get going with it. So it's really easy to build. That was one of the goals of the project too, was just make something simple that people could put together really quick. And the parts for this are less than $20. I mean, you can build it for, actually, I think the Lowland D32 Pro module is about $12, and then a DIN 6 plug and some wire is another couple of bucks. So it's really simple to build if you can solder 6 wires. I know that
You wanted to show something here?
Go ahead.
Were you going to were you going to show us something?
Oh yeah. Let me zoom in on this. This was another thing too. Programming it from BASIC is really easy, and this was the demo that I was doing for World of Commodore, and I did this on the fly, so I wasn't sure what I did wrong um, at that moment. And then after we finished up with the meeting, I figured out that my jQuery was a little bit off, and that's why it wasn't pulling the value that we're looking for. But this is a simple basic program, and this is accessing the device 16, which is the FujiNet virtual network device. And we're opening up command channel on device 16, then we're opening up a file channel, and we're reading HTTPS API chucknorris.io/joke/random. And this is a web API that returns some JSON data, and then we send a command that tells the device to parse the JSON, and then we do a query, a JQ, which is a JSON query on channel number 2, because that's where we loaded the data, and we're looking for this value, and that's the key in the JSON query or in the JSON data. Byte parse 2. This is a command that I added that just breaks the payload up into 80 character segments so that you can load it through an input command in BASIC. Because if it, in BASIC, you'll get a line too long error if you try to load something bigger than 80 characters or so. So what this does is it just breaks it up on the device side, and then we can read from the device the response, the payload from that jQuery. So let's run it, and over the internet. There we go. And so we just got something from the Chuck Norris API, and it's just a random Chuck Norris fact. So every time you run it, you get another quote, which is kind of neat. Again, it's real easy to program for this, so you can take a simple basic program, and now you've got internet interaction. You can load data from the internet. Kind of neat.
Yeah, very cool.
This is how we use an API that pulls the GPS coordinates for the International Space Station, and that's one of the demos that we use on for FujiNet. It's kind of become the Hello World program for all the different platforms, because it shows off a lot of cool features in that one simple little program.
So when you were creating the Meatloaf, what was your initial motivation to create this whole project?
Well, originally I started playing with the ESP8266 chips, the little Wi-Fi modules. I mean, they're $5. I mean, the ESP32 is like the new big brother to the ESP8266, and I just love the fact that you could get one little device for $5, and it has all this technology built into it. The very first project that I built with the ESP8266 was a lot of people were using it to grab data and do little control things that were connected to the ESP8266 over a Wi-Fi connection, right? Because you can connect it up to a relay and have it turn on a light or something like that just by accessing web interface and hitting a button, something like that. I didn't see anyone really using the access point feature of it, because it can act as a Wi-Fi station and also as Wi-Fi access point. And I was just kind of brainstorming, sitting around with some friends and telling them about this chip, and then the idea popped to mind. I was like, well, we should make it into a little Wi-Fi access point, and then when people connect to it, we can rickroll them, right? So, let me show you. If you search the web and you search for "never gonna give up free Wi-Fi," you'll find a Hackaday blog post from 2016 where I put this thing together and put everything on GitHub. You load this firmware on the gadget, and it turns it into a Wi-Fi access point. And this was back in 2016, where well, we've got Wi-Fi everywhere now, or all of our phones have internet built into them, unlimited data plans. Back in 2015, 2016, you were still looking for a free Wi-Fi access point to connect to, so that you could check your Facebook or log in and check into your location or whatever
Hmm.
from your phone. So people were looking for free Wi-Fi access points. So this was a just kind of a little prank. They would connect to my little gadget thinking they're getting free Wi-Fi because it broadcasts a SSID that says free high-speed Wi-Fi.
Hmm.
And then when they connect to it, they would get a page that pops up with some terms and conditions. And then whenever they actually hit accept on the terms and conditions, it starts streaming "Never Gonna Give You Up," and then you got Rick Astley dancing around the screen. It's just all of this is stored on the device, and you can pop a plug it into a battery and throw it in your backpack and walk around and Rick roll everybody. I called it mobile RR, or
That's
mobile
pretty
Rick roll.
funny.
Um, Actually, people have been building it ever since. So that's what kind of got me started with these chips. And then, of course, I saw Pi 1541 on Hackaday, on the Hackaday blog at whenever it got posted. And if you scroll down in the comments, you'll find a comment where someone had said something about porting it over, getting it running on ESP32. And I was like, yeah, I want to see that happen. And I was kind of waiting for somebody to do it for a long, long time. And then finally I was like, well, when COVID hit, I was looking for something to work on, and I had already gotten the Wi-Fi modem working, and that's when I start, again, I'd started working. I'd already been working on the IEC interface, and that so the actual idea popped into my brain a long, long time ago when Pi 1541 came out, and that was kind of the inspiration for getting Meatloaf going. Um, so I did start porting Pi 1541 to the ESP32. I didn't get too far with it. I still believe that it's possible, and maybe we can do a cycle exact um, you know Pi 1541 on a ESP32. I don't know. Maybe it's not fast enough. I don't know.
Lucas,
Um,
did you have a question? You unmuted there.
Yeah, yeah. I
sure.
had two questions. One is completely random. Is what is the Atari font CSS? What are you using it
Oh, that I had loaded. I use the same board for both FujiNet and on the PCs and on the Meatloaf side, and I had flashed it with the FujiNet file system. And we have on the original FujiNet, we have the Atari font in there, and it's just residual from flashing it with multiple different firmwares. So I'll work on Meatloaf, get some things working, and then I'll merge that over into the FujiNet source code for the Commodore stuff. And sometimes I'll work on the FujiNet side and then merge things over to Meatloaf. So I'm constantly
Yeah.
back and forth between the two. But that's what that was, is
Yeah.
just some leftover files from working between the two projects.
Well, the other thing was like you were showing us before this I think it's a web application where you can see the drive or the map of a drive and where the files are.
Oh yeah, no, that was connecting to the Meatloaf device using WebDAV. Um,
Oh, okay, yeah.
WebDAV is a HTTP based file system for editing files on a web server. But I'm
Oh, okay,
using
okay,
it.
okay. I thought that was your project. No.
Oh yeah, no, WebDAV is a standard. It's a standard for accessing and editing files on a web server, and I implemented it in
Oh yeah, but you did a visual representation of.
a visual representation.
You were showing us something where you were dropping files and looking at the mapping of a drive before we started the meeting.
Oh, before we started the meeting?
Yeah, I thought you wanted to.
Oh, right. Okay, sorry. That is that's another project, and I did mean to talk about that. Hold on one second. Let's switch back over to the browser. And this is, I call it Meatloaf Media Explorer. Let's refresh. This is a project that I was working on, and I when I was working on the D64 file formats and all of the different file formats, I got tired of going, every time when you're working on a microcontroller, you have to write some code and then compile it and flash it and then test it, and then you make a tweak and then you have to compile it and flash it and test it. So that cycle of compiling it, flashing it, and then testing it is very slow. So I had the idea to just build something that I could use to work on the code faster. And so I ported all of that C++ code over to JavaScript and wrote this Meatloaf Media Explorer so that I could work on the file format stuff inside of a browser. And also, Durmaster there is a version that's being worked on that is cross-platform, but and you can also run it in Wine on a Mac. And I primarily, my main system is a MacBook Pro, because I can bring it back and forth wherever I'm at, and I can work on stuff across all platforms, Mac, Linux, and PC, or Windows. So I wanted something that I could use in a browser, and I put this together. Let me see. I will show you. So again, you go to Meatloaf.cc/tools/mme, and you bring this up, and then you can just drag a D64 in there, or any of the supported file formats. Let's see, let's do test demo. I'm going to drag this in there and drop. So this browser application just read that D64 in the memory and just decoded everything. It knows it's a D64. It's a disk. Oops, hang on. Where's my dang mouse? There it is. Okay, so it's a disk. It's got shows you all how many blocks are there. If this was a 40 or 42 track disk image, it would show you that as well. It tells you whether there's error information available in the D64 or not. If there's a BAM message, it'll show you right here. I actually have some. Let me see. One moment. Let me find. Well, I've got some sample disk images that have all this different stuff in it. Let's see. Where's Meatloaf? And then SD card, and then test. Okay, let me drag this over here. Oh no, that's a little bit, that would be in the way. So anyway, let's see. Like, here we go. Here's a 40 track disk image. Let's drag that, drop that in there. There you go. See, it's 40 tracks. No error info. Let me show you one with a BAM message. Let's see, BAM message. Here's a disk image with a BAM message in it. So, right there. So that's the message that's written in the some of the free bytes in the BAM sector. Which people did that back in the day, I guess. I don't know. I never knew it was a thing until I started working on the disk images and stuff. So this shows you the directory listing. I can click on one of these files, and then over here it shows the specific information for that file. And if I wanted to extract this, I haven't finished building this, so the web interface, I need to add some more elements so that you can get to some of the functionality in a more intuitive way. But once you have a file selected here, you can click anywhere in this file block. If I double click that, it's going to let me download that PRG file directly out of that disk image that I dropped on it. I can save that to my computer and then run it in Vice or something. It shows all of the blocks that that file takes up. And if I click on one of these blocks and then I scroll down here, it's going to show me that's where the block is in the disk image. All of these purple ones are all the blocks that make up the file that's selected above. And then this shows the dump of that sector on the disk, and then just a PETSCI, version of the data that's in that block as well. If I want to click around in the disk image, so I can show you, it's highlighting the track, but also highlighting the sector. So if I want to see what's in that sector right there, I just click on it and it shows me what's in that sector. This disk map, you can rotate it. If you click on the header, it'll rotate the disk image so that it's sideways instead, which in some cases it's a little bit easier to read there. You can just click around and explore the different blocks that make up that disk image. Let me show you. It does a let's see, where's a D71? D71. Sweet, I guess I don't have them here. Oh, I don't have a D71 in this folder. I can do a D81. Drop that. Of course, that disk map is going to be a lot bigger.
Yeah, I can see that.
Yeah. And all of the tracks have the same number of sectors, so it's just a big square, but you can do the same thing. You just click around in here and then see what's in that sector, which is kind of neat. And again, I was using this as a test program to write the code for Meatloaf to do all of the disk format stuff.
What's the website again?
It's meatloaf.cc/tools/mme. It's right here at the very top.
Yeah, it's a little blurry, so that's why. Okay, so
Okay, sorry about that. Yep.
I'll post it.
Yep, meatloaf.cc/tools/mme.
All right, got it.
That's available right now for use on the web. Actually, let me show you this too. If you go over to CSDB and you want to look at something that's on CSDB, say, let's pick something random. I'm just going to hit random. Okay, and I'm gonna do that's a PRG file. That's here. Let's pick something else. I want a D60, something that I know is going to be a D64. Let's see, random. Well, that's PRG2. Hang on. Oh, there you go. There's a D64. So I'm going to come here, right click, copy this link address, and then you go over to Meatloaf Media Explorer and pop that in. Paste, explore, and it'll load it right from CSDB. Oh,
Wow.
there it goes. There you go. It loaded that right from CSDB. So now we're looking at the disk image from that file from CSDB. Let me show you this too. This is kind of cool. Let's go home. The web version. Let's see. Edge of Disgrace. Here we go. This one's kind of cool. Let's go to Edge of Disgrace. This one is a zip. Right click, copy link address. Now we go back over and let's paste this link in. So this Meatloaf Media Explorer is usable by other sites too. So if you want to have a link on your site that uses this, all you do is you do the URL to meatloaf.cc/tools/mme, and then you do a hook, question mark, and then the URL to the file that you want to load up. So you can create a link that goes right to Meatloaf Media Explorer and then loads up whatever file you want, wherever it may be on the internet. This one is actually a zip file, and it's got 3 different disk images in it. So it shows you this archive block, and you select the D64. You select that. Now it decodes it. And we got the media, we got our directory, everything. And if I come over here and I select one of the others, it's going to switch it out. You can see the directory art and everything is kind of neat. So
Yeah, it's pretty cool.
it's a neat little tool, and it's accessible from your web browser. So no matter what system you're on, you can get to your you can explore the disk images and extract files out of it. Again, if I select one of these files, like that right there, my system's running a little slow. There we go. Now in the file block, if I want to save that file, the one that's selected, I just double click in here. I need to add a button or something. You just double click in that block anywhere, and it'll download that as a PRG file and dump it to your local system, so you can load it up, do whatever you want with it. So that's Meatloaf Media Explorer. And I still have some work to do on that too. Eventually, I want that to support not just Commodore file formats. I want it to support every 8-bit or 16-bit file format out there. I want you to be able to explore any kind of disk or tape media using it. So that's kind of a separate project by itself that I enjoy working on these media file formats. It's kind of like solving a puzzle and getting the code just right so that you can see what's in there. It's kind of it's fun.
Yeah, very good. Does anybody have any questions for Jamie? Lucas, is there a time limit on this talk, or do we have to stop at a certain point?
No, but
All right. Well, if there's no questions, I
Yeah.
think we could end the meeting.
Okay,
Thank you, Jamie. This is great stuff.
awesome.
I can see that you keep working on this stuff. Do you ask for other people, or is this some project that you're gonna just can work on your own?
I'm happy to have any help that anybody wants to supply. I have a Discord for Meatloaf. There's also a Discord for FujiNet, of course. If anyone wants to build one of these, hop on in the Discord. Happy to help you get up and going. And if there's any features that you want to help work on or test or anything that you want to do, happy to have people join in and help build this thing out. I've got a huge list of things I want to do, and it's me and just a few others that work on it whenever we can. Of course, there's some guy, some of the other FujiNet guys are working on the FujiNet side. And of course, we're sharing code between both sides, but some of the Commodore specific stuff, I think, it'd be nice to have some other people helping if there's anybody that wants to jump in and help. So,
cool.
So how would they get in contact with you if they are interested in helping?
the Discord is probably the best way. There's a link to the Discord on the Meatloaf GitHub, and if you go to Meatloaf.cc, there's links there as well.
Okay, that's wonderful. Well, thank you, Jamie.
This was
Thank
great.
you.
Yeah.
This is great stuff. Anything to enhance and extend the life of these vintage computers that we all love is welcome. Makes it easier to work with them, and as the physical media starts to deteriorate or just becomes cumbersome to use it. Plus, the physical mechanisms of these things start to stop working. I hear about certain 1541 drives that just don't work. With certain defect that you can't fix it. So this is great to have modern methods to continue working with these old computers. It's wonderful.
And one of the things I love about this is we're mixing retro 8-bit stuff with cutting edge internet technology. I've also been working on a IPFS protocol for Meatloaf. And I don't know if you're familiar with Web3 or DWeb. It's peer-to-peer. So you would be able to use a content identifier to locate a file out on the internet using an IPFS URL and Meatloaf. So it's not You know, it's kind of cool, cutting edge technology, and I want to get all that working as well too. So this is the project where I test out all the stuff that I'm interested in playing with.
What about what are the Apple Vision glasses where you can actually then you can make one where you can have like this file structure right in front of you. You can physically manipulate it in the air.
That
It's
would
a
be
whole
cool.
nother level.
I do all these things, all of these things.
Here, grab this file. That's pretty soon we're gonna have stuff like that where we could just like,
Yeah,
augment the reality.
awesome.
All right, wonderful. Well, thank you, Jamie, again.
Thank you.
It was wonderful to have you talk here, and thank you everyone for participating. Once this talk will be uploaded to YouTube later after editing, so then everyone else can enjoy it.
Okay, awesome. Thanks.